Good evening, everybody, or good day. Can anyone hear me?
Yes, we can hear you.
I'm greeting. No, hello, nothing from anyone. Okay, great. Thank you. Good evening, everybody. We will start shortly. Thank you for joining us today. Prof. Agaku, please let me know. Are you here yet? Not yet. Hi, squeezing. Okay. All right. I'm making you a panelist, Prof. Please accept. Okay. Do we have people joining us for the first time? Just checking so I can introduce our speaker, or do we all know him? Thanks, Dr. Marva. Okay, I think I see familiar names, so I don't think we need an introduction. And I believe you all know the rules. And yeah, okay. Prof, are you
Yeah.
ready?
Yes, I am. All right. Let's get started. So I have two screens, so I'm looking away because I'm on screen. Alrighty. Pull up my script slides. Please, can you allow sharing of screens? I can't share.
Okay. And now?
Okay, it says multiple presenters can share. Is that a correct statement?
Yeah, I'm not sharing screen, so it's either one participant or multiple. So I've just selected
Okay.
multiple.
I guess I'm just having PTSD, so
Yeah.
alrighty.
Understandable.
Use my screen.
Loading.
Okay. Yes.
If it's just my
I'm still loading.
network. Still loading. Maybe others can confirm. Yeah,
Yes, nice
I see
showing.
it now.
Is it showing? Looking at the can you confirm, please?
Yes, sir. I confirmed. Sorry. Thought you heard
Okay.
me.
All right, sure. Okay. And it's full mode, right? If the full screen mode.
Yes. Yes.
All right, awesome. All right, welcome everyone. Today we'll be taking a gentle introduction into data analysis. The sessions do not assume any knowledge. So we don't assume that you know anything about data or analysis. And so build from ground up. We will divide the class into 3 sessions, each with increasing level of complexity. So today is just going to be easy peasy, right? And then tomorrow we'll build on that. And then the next day we'll then put everything together. So let's start. So what really is data analysis? Well, it's all about sorting things. So if this is our data, analysis allows us to, well, sort things. So if you have a pile of toys or Legos, you can say, all right, I want to sort them into black colors and yellows and reds, right? That's essentially what we're doing in analysis. We take whatever data we have and we try to make sense out of it. So sort things, we can arrange Legos into shapes, we can present. At the end of the day, the value is actually in telling a story. We want to move from this, so that this came from this. The way it is meaningless. It's just a pile of nothing. But out of that comes this beautiful stuff. This tells us that these shapes we have here have infinite potential to generate anything. We could have decided to build a car, or we could have decided to build a train. So that means that the story that comes from the data is a function of what our objectives are, right? Any story can come out of the data. It depends on what we want to communicate to the audience. But the big message is that data is not the same as information, right? Data, we analyze data so that we can get information. So this arrow here, this is where analysis comes in. We take data, we analyze it so that we can derive information or insights from that. So that's the clear distinction between data and information. So the question is, what is data? Well, first things first, data is plural. I'm going to hand up.
Oh, your screen was frozen. Sorry. Seems your network is not so good today. Are you in Wakanda?
Is it still bad?
Yeah.
Oh, really? Okay, hold on a minute. Let me switch. I switched internet provider today, so maybe that was not a very good idea. Let me quickly switch to. I may drop off if. Let me see. All right. Am I still on?
But you stopped sharing.
All right. Yeah. I'm going to share in a minute. Okay.
Okay. Yeah, even your video. Shame.
Is it better now?
Yeah. Yeah, it is. Thanks.
Okay. All righty. Well, if it's not better, you guys just have to deal with it.
Yes.
All right. So let's start with the basics. What is data? Well, first thing we want to learn is that the word data is plural. Its singular is datum, right? So that's why we don't say data was analyzed. That doesn't make sense because data is plural. Data were analyzed because data is plural. So a datum or data refers to a single piece of fact. So any fact is data or datum. Anything can be data, right? If you look, for example, at if you buy an item and you're given a receipt, that is a piece of data, right? Because you have information on that receipt. You have things like how much you paid, what item you purchased. Now, that single receipt in your pocket is not necessarily interesting. Like, I'm sure all of us have a piece of receipt in our pocket. Take it just by itself, that is not interesting in any way. Now, but what happens if you now collected all the receipts from everybody in the world? Now, that becomes a trove of information, right? That becomes gold. Because even though one item is not interesting, we'll put everybody's information together, we get real gold. And so here, for example, we can choose to have a data set that has the date of purchase, the type of payment, whether it was card or whether you used cash payment, where you bought the item, whether it was in Boston or Johannesburg, and so on and so forth. And then we can now start to analyze. We can now start to say, oh, wow, the people who buy things with cash, are they more likely to buy certain things than other things? Right. So that's so that we want to think of anything you're looking at is data. So if you look around where you are now, anything could be data. The TV you are watching from, the chair you're sitting on, those are all data points, right? The question then becomes, is it of interest to us for what we're trying to do? And so that's the lens through which we wish to look at the world, that every single thing could potentially be a data point for analysis. So what does analysis mean? When we say we analyze data, want to analyze data, what are we exactly saying? Well, there are two things we're trying to do. We're trying to compare or to describe, right? So we can narrow down all the complexity to just those two things, to describe or to compare. I'm sure you've heard someone say, oh, I don't compare myself with other people, I just focus on myself, right? So in life, there is this understanding that those are two things that could happen in any context. We can either just describe ourselves in isolation, or we can compare ourselves to our neighbors, right? And we generally want to say, oh, we just try and focus on ourselves. And that's how it is in analysis too. Every kind of analysis is simply, you can put them into those two buckets. You're either describing where you're just focusing on just telling a story and not necessarily comparing to any other thing, or you compare. So that's what we're trying to do in analysis. We either describe or we compare. It's as simple as that. Now, when we're describing, think of describing anything. What are some of the scenarios that we might encounter? Well, you might describe one item only. Here, for example, I'm looking at this boy and he's looking at his height. So I can say, well, Johnny is 2 feet high, or he's about 4 feet high or tall, right? I'm just focusing on him alone, right? In that context, I'm describing, I'm saying, oh, wow, last year, I can't believe how much you've grown. You were this tall last year, now you've grown to this tall. Now, in analysis, or in population research at least, we're not just looking at Johnny alone. We're looking at Johnny as a group, we're looking at the transition from an individual to a group of individuals, right? So instead of saying, oh, Johnny is 4 feet tall, we might say the average height among boys is 4 feet, right? So, but it's just like looking at just an individual. There's not much difference. Just that in this case, we typically try to look at it from the level of population, not just an individual, right? So this is what we call univariate analysis, because we're looking at one parameter, just a single parameter, just height. We're saying Johnny's height is 4 meters, or the average height in the population of boys is this. Just one parameter, we're looking at one thing, and that's why we call it univariate. The word uni means one. Think of unity. When we say we're in unity, it means we're at one. So univariate means one. Well, we can look at two. Remember we said analysis is either to describe or to compare. Now, we're not just interested in describing Johnny's height. We're trying to compare Johnny's height with that of Amelia. I would say, oh, Johnny, you're shorter than Amelia, right? So in this case, we're comparing. Now, if we drag this out to the concept of analysis, we're not just looking at two individuals, but we're looking at two groups. So we might be interested in comparing the height among boys versus girls. But now it's comparisons, right? And so that's an extension of what we just did earlier. Now, since we're looking at the height between boys and females, now we have two variables involved. It's not just the height, it's height on one hand, and on the other hand, gender. So since two variables are involved, this is what we call bivariate. The word bi means two. Now, sometimes we have comparison with background noise. So you look at Johnny versus Amelia, and you're like, oh, Amelia is taller. But then somebody says, well, she's taller, but that's because she's from a richer family. It's like, okay, what does the rich family have to do with this? And then the person says, well, if she's from a richer family, then that means that she eats better food. That means that it's not because she's biologically taller, but just because she has access to better food. And then it's like, okay, how do we then remove the effect of her family wealth out of the picture? And that's where we talk about multivariable analysis, because now you don't just only have the gender and the height, but now you have to deal with some other variables, which we call confounders. We will not talk about all of that today, but when we have other noisy influences coming into the picture, which we need to take care of, that's what we call multivariable analysis. But again, today we're just setting a picture for what we'll expect in the next few days. So the goal of analysis is to simplify the data, is to reduce the dimensions of data. In other words, we want to take something big and make it small. We want to take this data set we have here and just reduce it to a small number and say, mean value was X, or X% reported Y. See, that's summarization. If your analysis ends up making things more complicated, then you're on the wrong track, right? The goal of analysis is to simplify and give us insights so that we can make use of those in our work. The second goal of analysis is to separate truth from chance and bias. Research is all about finding truth from chance and bias. It doesn't matter whether you are in sociology or you are in, medicine, whatever. We summarize epidemiology in 3 words: truth, chance, or bias. In other words, we're saying that anything in the world, any observation we see, any phenomenon we observe can be explained by one of those three things: truth, chance, or bias. We want the truth, obviously, but the truth is not just isolated. The truth is not just hanging in space just by itself. The truth is usually entangled within bias and entangled within chance. So the question then is, how do we separate the truth from chance and bias, right? That's the second reason why we analyze data, to make that separation. So that's the point we do. We want to summarize information, take something big and make it small. And we also want to make sure that while we're doing that, we are saying the truth and nothing else but the truth. In other words, we have control for the effect of bias and the effect of chance. All right, now let's move on to the next step. We need to understand what we mean by data. What does data look like? Again, we are not assuming any knowledge. So if this is a bit elementary, that's because we don't want to assume knowledge and we're just going to build from the ground up. So this is a data set. A data set is a set of data points, right? And remember, anything here is a data point. This is a data point, this is a data point, this is a data point. We'll put different data points together. We have a set of data points, which we call a data set. Is a set. And so typically, there are different types of data sets, but the kind of data set we use in analysis most of the time is a data frame, which is like a spreadsheet. We have rows and we have columns. So here, for example, we have these rows. Each row represents an individual. So for example, Avery and John and Jonas and Jordan and so on. They are the rows for analysis. And the columns represent the variables, which are the things we're interested in analyzing. So when we say we're doing analysis, we're saying for each of these variables, how do we describe this variable as an average in the whole population? That's essentially what we're doing. Now, variable, you cannot mention the word variable without mentioning the word vary. So that means that to qualify as a variable in analysis, you must first vary. If all individuals have the exact same value for a column, we can't use that column in analysis because it doesn't meet the fundamental requirements of a variable. It does not vary. So to be a variable, you must vary. So that's very important. So here, everybody has one. Not good. We can't analyze it. It's like there's no variation to describe. Everybody has 0 here. Not good either. How do we describe variation? Now here, this is good. Some people have 1, some people have 0. That's good. We can analyze that because it varies. So in other words, it's a true variable. So to use any variable analysis, you must first vary. Now, let's talk about types of variables so that we're all on the same page. Here are some types: continuous. Here, there are some misconceptions about continuous variable. People imagine that we call it continuous because it goes on forever and ever and ever. So you have 1 billion and 1 trillion and it keeps going on and on. That's not what we mean technically. What we mean is that pick any 2 values for that variable. Let's say pick 1 and 2. In between 1 and 2, there is an infinite possible number of values that you could have. So a continuous variable, for example, you could have 1.0001, 1.00002. You could spend all of your life counting the possible values between 1 and 2. That is what we mean when we say the variable is continuous, because there's a continuous stream of values between any 2 points. It doesn't matter what 2 points you pick. I could pick 1.1 and 1.2, and I could spend all eternity counting the possible values between those 2 points. That is why we call them continuous. Count, however, is different because it means that if you pick any 2 values, any 2 points, there are no values in between those points, which is different from what we just said about continuous, that you have an infinite number of potential values in between them. Ordinal, as the word implies, means there is order. Things are ordered, like first position, second position, third position, there's an order there. Rich, poor, middle class, there's an order there. Then nominal means there's no inherent ordering. It's just a group. For example, if you look at on your phone, you have 1, 2, 3. It doesn't mean that those characters are different. Or if you have gender, male, female, order, there's no inherent ranking of that. So that's what we mean by nominal. Nominal comes from the word name. You are it's in name only. It's not inherently ordered. Now, for continuous variables, there are two subtypes of them. Ratios versus intervals, right? And it's very easy to know this. Ratio ends with O. That means that ratio variables ends in the true zero. That's an easy way for you to know it, right? So if it ends in the true zero, it's a ratio. In other words, a ratio cannot have a negative value because the lowest value it can end is 0. So that's, so if you think of any variable that will have negative values, then that tells you that's an interval and not a ratio. All right. This is now practice time. This is now when we'll do a quiz to see whether you guys have been following. All right. Practice session. What kind of variable is this? I can't see what people are typing, can I? Lungi, do you want people to unmute and answer, or do they just type in and...
We can type.
All right. So, is it option A? You can just type the letter that corresponds or the number.
Oh, you can't see?
I know I can't see anything.
Oh, okay, sorry. Count, count, count.
All right, count. That's up. That's
Okay.
So this is count. So let's go on to the next one. What kind of variable is this? The hint here is that you can look at this is the hint you want to look at.
Nominal. Nominal.
Okay.
Interval. Continuous. Ratio.
All right.
Interval.
So the correct answer is an interval, because remember, this is temperature is continuous. It's a continuous variable, but here it's saying you have negative values, right? You have sub-zero. In fact, the name itself is obvious. Sub-zero temperatures. Temperatures below zero. And remember, we said ratio ends in O, which kind of looks like 0. So you can't go below 0. So the only option there is interval, because it can fall below 0. So that's why we call it sub-zero temperatures. All right. And what variable is this?
Continuous.
No,
Ratio. Continuous. Count.
excellent.
Count. Continuous. Ratio. Ordinal. Ratio. Count.
Okay.
Ratio.
It can be count, because
Ratio.
between 2 meters and 3 meters, we can have 2.1 meters, 2.112 meters. That's why it cannot be count, right? So the only answer here is ratio. Count and intervals are very similar. Every count is count and discrete values are similar, because every count is a discrete value, but not every discrete is a count. But the correct answer for this is a ratio. And what of this? You have race, ethnicity, American Indian, white, black, Asian, Hispanic. What variable will you call this?
Ratio. Nominal. 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 Ratio. Ordinal. Nominal.
It's nominal, because
Nominal.
there's no inherent ordering of the groups. You can't say white, it's first category, then black. No, that makes no sense, right? And so that's why it's well, when you do that, it's a name for it, right? We call it racial supremacy. That the reason why we call that, there's no inherent ordering. They are nominal variables, so we don't assign order to them inherently. And here, poverty level. What will you classify this?
Ordinal.
Excellent. Ordinal, because
Ordinal.
now
Ordinal. Ordinal.
an inherent ordering of the variables. And what of this data set here? This is a curveball. We didn't cover this, but I expect you guys to answer.
Unstructured. Unstructured.
Unstructured simply means, as the name implies, it's not structured into nice, rows and columns. It's just, context. So, all right, now let's move on. So when we analyze data, remember we said we want to, from data, we want to get insights. The question is, who does this data apply to, right? The issue of generalization is always a big question we need to figure out. I'm sure most of us are in the audience here because it's not just that we want to know about analysis, because we want to write papers and publish them and be able to say something meaningful. So our session will be incomplete if we don't talk about the differences between the sample and the population, right? Whatever data you're analyzing is the sample, and the goal is to make inferences from the sample to the population. And this is what we call the cycle of inference. It's a cycle because it goes round and round and round. The population gives birth to the sample through the process of sampling, and the sample gives us estimates that we can then use to make inferences to the population. And then we take another sample to get through sampling, and then we get another estimate, and the cycle goes round and round and round. Now, there is, however, an assumption that under which we can keep making this cycle go round and round. We are assuming that even though the sample is much smaller than the population, it looks like it's like a mini version. Think of it like when you sometimes some kids look like their parents so much that when you look at these kids, like, oh my goodness, this is you are really your father's child, right? Because they look so much. That is exactly what we want the relationship between the sample and the population to look like. We want the sample to be a spitting image of its parent, which is the population. When that is the case, oh, everything is fine and good, right? And we can keep making these inferences. So the sample must be a spitting image of the parent population, even though obviously it's smaller, right? The way it looks is distribution of variables. So what this means is that if the parent population has 50% males, we expect to see 50% males in the sample as well. Now, in the real world, this is never the case, and there are ways we need to correct for that. Again, we're going into some details under the assumption that your goal at this session is to be able to analyze data sets and publish. So when this assumption is not met, we deal with it a particular way. Sometimes this child does not look like a parent at all. This child looks very different. I like, where's the resemblance? Like, it's very hard for me to believe that this is your child because you do not look alike. So the question is, when that happens, what do we then do? How do we correct for that problem? Well, we use weights, right? So, well, you don't have to know the theory, but you have to know at least the idea of what we're trying to achieve. The problem we're trying to solve is that the sample does not look like the parent in any way. And we want to force this sample to look like the parents. It's like, this child, you must look like a parent, whether you like it or not, right? We force the child to look like a parent. And that's why we go into all the world of weights and PSUs and stratum. It's just a way for us to ensure that this cycle of inference is maintained, that the sample can then look like a parent, so that we can make valid inferences from a sample to the population. All right. You don't need to know the theory. You don't need to be able to write a line of code. We're going to show all of this in the next, in our webinar series. But here's how you can also think about it. That we talked about 3 variables here: weight, PSU, and stratum. I want to take a minute to explain what they do so that we're all on the same page. Things like this don't exist anymore. But for those of you who are old school, you might have had a stereo. You have a balance button and a volume button, right? The volume increases the pitch, it's like, the loudness of the music. The balance just adjusts the bass between the speakers so that they are all like, vibing at the same frequency, for lack of a better word. I'm not a DJ. So that's the exact same thing we want to do with our surveys, right? We want a button that increases the volume up and down. And then we want another button that controls the spread of the music. And that's what these buttons are doing: weight, PSU, and stratum. The weight increases the volume. They estimate whether it's high or low. And the PSUs and stratum controls the confidence interval, right? So one controls the point estimate, the other controls the confidence intervals. That's what they do. So that means that if you have only volume, but not this, it means the up and down function will be regulated, but not the left and right function. The same thing applies here. So your job is just to understand conceptually how these things work. You don't need to know all the nuances or the mathematical proofs, but you just need to have an idea that, okay, I want to publish a paper from a complex survey, and I have gone through the data set and I know I've seen that there's a variable called weight, and I've also seen there's a variable called PSU and stratum. At that point, you should know that, okay, I need to account for the weight variable in my analysis. Why? Well, going back to this, because the child does not look like the parent, and we want to make sure this child looks like a parent so that we can make inferences from the child to the parent. That's all we're trying to do. And that's all you need to know. That's just the amount of complexity you need to know. Nothing more is required. All right. So this is putting it in a visual form. What weights do is, this is our parent population, and this is the child. This looks nothing like this. So what we're doing is that we're going to take this, the weights, what they do is that they take this data and they force that child to look like the parents. So this is your data before it was weighted, has no resemblance to the parent. What weights, when we do weighted analysis, is they take this same child and force it to and create something like this. Now, question is this child a perfect replica of the parent? Still no. Does it look like the parent close enough? Yes, it does, right? And that's what we do in analysis of weighted data or complex data. We take our weights and we apply them, and what it's doing is that it's forcing the sample to look like a parent so that we can continue that assumption of representativeness and continue the cycle of inference. That's what we're doing. All right, so what we're going to do now is we're going to look at some data. For all of our sessions, we're going to use the same data set so that we don't get confused, and we will just look at a different angle of it for a particular day. So we're going to look at NYTS data. This is a snapshot of a data set. This is just to show you how it looks like in the data set. So you have the PSU variable, you have the stratum, you have the weight. You see fin weight, that's the final weight. So whenever you download the data set from a public domain, the names may be different, but they always look somewhat alike. So you always see a variable called something like PSU, if it exists, or something like stratum. It may not be stratum in full, but it will always be like strat or strata or something. You can't miss it. Typically, they're always at the extreme of the data set, either at the very beginning or the very end. That's how you can recognize them. But please try and read the documentation to know what the variables mean. And you also see a variable that is weight. You might see fin weight. Weights are always positive numbers. They can be negative numbers. For design weights like this in large surveys, they can be 0. They are 1, minimum of 1 and above. And a weight of 4.1, for example, this one value means that this guy in this row represents 4 people that look like him. So he represents himself, obviously, and then he represents 3 other people. So altogether, he represents 4 people. That's what that value of 4 means. A weight, this guy here, 3954, means that this guy represents 3,954. Well, that's a lot of people he's representing, right? And so if you add up all the weights, you are going to get a total population size. So if this is a survey of all of the US, you are going to get population of the US if you add up all the weights. So again, you don't have to know all the details in complex survey analysis, but what we've just covered is sufficient for you to be able to do your analysis. All right, that's a theory now we've covered. So now what we're going to do is we are going to go in and see how we apply all of those things, how we import data into software, how we look at the visualizations, the types of variables. So all of the things we've covered now, we're going to look at them in practice and see how they all apply. All right, let's go over to, so we're going to use the Chi-Squares platform. For those of you who are not familiar with the Chi-Squares platform, it's a one-stop shop for every single thing that is research. You can do your surveys, do your analysis, and do your manuscripts and everything in between. It is designed intentionally to be super, super, super simple to use. So we targeted an 8-year-old child. Okay, if you're an 8-year-old child, you should be able to work on the Chi-Squares platform and do whatever you need to know. So that's the premise, the context that that covers the philosophy behind how we've engineered it. So if you don't have an account, you can sign up. If you have one, you can log in. I'm just going to log in now. I've already logged in. So this is the dashboard. You can always change it. I always prefer working in light dark mode because it's just easier on the eyes. So I'm just going to go ahead and use dark mode if that's okay. I'm looking, is it very clear in dark mode, or should I just switch to light mode?
It's clear. It's just very small, but it's clear.
Alrighty. Okay. So this is the dashboard. And this gives you access to the different features on the platform. For data collection, you can design your surveys. This is the survey, for example, we use for folks to register. So the data were collected right here on the platform. And so you can design whatever surveys you are conducting, whether they are cross-sectional surveys or longitudinal studies. That is all supported on the platform. You can if your survey has incentives or whatever it is you're trying to achieve, you can apply them from the settings. We're not focused on surveys today. So I'm not going to go straight to our business for today, which is analysis. So you come over here to data analysis, and first order of business is for us to import the data for our analysis. So you can start a new project and give your project a name. So we're going to call it day one of analysis workshop. Whatever name you choose to call it. You can provide a description. Today's session focuses on descriptives. Again, just for your own memory so that you can always remember. All right, now you can upload your data. There are different ways you can upload data. You can upload from your computer. So you might have a file. The platform supports upload from different formats, whether it's SPSS or Stata or SAS or whatever file type you have. This is an Excel file, for example, and I got this file from here. So you can download this file if you wanted. Let me drop the link in here. Okay. And I'll import. So it imports the file. So now what it's doing is it's validating the data, because it reads the data and then it goes through a series of processes to scan for missing values, to check other irregularities with the data. One of our philosophies in engineering is that we try to build a lot of forgiveness into our products. So that means that if there's a problem with your data sets, the platform scans for it, and then it tells you that, hey, here are the problems we found. This variable makes no sense, or there are huge issues here, and here is how you can fix them. So that way you can, even if the data set has a problem, the issues are flagged and presented to you to fix them so that you can continue with the analysis. So that is what is going on in this phase. It's preparing the variables for analysis, and that includes running those validation checks to see where things are wrong. Things that could be wrong might be entire columns that are missing, which may be a mistake from where the data came from. It could be that you have variables that have, disallowed characters. So disallowed characters could be things like punctuation marks. In general, variable names can only be made up of alphanumeric characters. So A to Z, 0 to 9, and maybe underscores or full stop. But if your variable name has other things that are not allowed, like question marks, well, it will flag it. If it's taking too long, you can always hit this refresh button, and that will pull up. For example, in this case, that was good to do that. Now, when the data set is imported, you can see this part here is what we call I think somebody said we should expand let me expand it a bit. So, any better?
Yes.
Okay.
That was the
All right.
request.
The downside to that is that I will have to be moving the screen manually, but I have to manually zoom out. So here you have the variable name, the variable type, the unique values, missing values, and actions. So let's map this back to what we learned. So here we have this variable continuous, right? And Mel said a continuous variable is one where between any two values, you have an infinite possible values that you can take. So here, for example, you see this are the values. This has 30.73 something, something, something. That definitely makes it continuous. You can also visualize the variables that you have imported. A huge part of data analysis is data visualization. You should develop a love for visualizing data. Don't just jump into analysis without looking at what the variables look like. So we've provided you with all the tools for your visualization. To visualize, just click this button that says visualize. Very intuitive. So here you have a plot of a variable with the errors. You can also choose to express that as a box plot, in which case it's going to plot the data accordingly that way. If it's a categorical variable, like this one, it will show appropriate figures for that. So in this case, you have a bar chart. I can change to a column chart or to a pie chart, as the case might be. It's great for you to visualize your data this way so that you can see what to expect, and make changes as needed. String variables are variables that contain letters. For example, if you look at this variable here, let's look at what's in there. So string variables are visualized with word cloud. And so you might want to look at them and say, okay, what is in here? So in this case, there may be some elements here that it was captured as string. It looks like numbers, but they're not actual numbers because of the way it was captured. And so visualization can help you to see that, okay, this variable was supposed to be a number, and that helps you detect irregularities in your data. So that now, if I wanted this variable to be in numbered form, to be counted as a numeric variable, I can simply respecify it as numeric. So that the platform will then treat it as numeric, right? So this is why visualization is very important. Now, remember we said that for a variable to be a variable, it must vary. So if variables do not vary on the platform, you cannot analyze them. Let me see if there's, these variables, for example, all of them only contain one. There's only one unique value, so it's not a variable in the context of analysis. And so that's why we classify those variables as indeterminate. We can't truly classify them as categorical because they don't have categories plural, right? It only has one unique value. And so for the purpose of analysis, you can't really use those variables for analysis because they are indeterminate. So the first part of analysis is just looking through your data and trying to make sense of it, whether it's categorical or continuous. And then it's also very important to look at missing values. The platform readily supplies to you the number of missing values so that you can take action. If, maybe it may not be a very good idea to include a particular variable in your analysis if it has so much missing values, right? So this is all provided for you without having to do further analysis. There are some things that are just so fundamental in analysis that they're so important that we shouldn't have to make you go and click an extra button or write some extra code just to find what they are. Things like, number of missing values, they should be readily available for me to use them whenever I want, right? So this is what that means there. Then these buttons also allow you to describe your data. So visualize, we've already covered it. It allows you to visualize your data. I may also want to look at the summary of the data, which is this button here. When I click it, it will provide the summary of the data. So here, I know that the values are 1 and 2. They count and percentage respectively, 249 and 1.4%, and so on and so forth, right? This allows me to know at a snapshot what these values are. And really, there are two unique values, which are 1 and 2, and that total number of missing values, 544, right? So that's the information I get with the summary button. Of course, this is for discrete variables. If it's if a variable is continuous, the type of, let's look for a continuous variable, for example, and let's look at the summary measures displayed. So here we'll have the unique values and also the 5-number summary. The 5-number summary is a set of numbers that give us an idea of a distribution of a variable. So the 5-number summary includes the minimum value, which is the mean, includes the first quartile, which is the Q1. It includes the median, which is what we have here, which is the second quartile. Then we have a third Q3, and then we have the maximum, right? Q3 and the maximum. Those make up the 5-number summary for a continuous variable. The mean is technically not part of a 5-number summary because it really has little to do with the distribution in that purest sense, but it's also provided here for you so that you can access it. So the displays that are shown on that summary are a function of whether the variable is categorical or continuous or string or whatever. So the platform automatically detects the kind of variable and gives you the appropriate summary statistic for that variable. Then here you can write notes. You can add tags to a variable. You can add notes. If you're working with a collaborator, you might say, oh, this variable is bad. Let's not use it, so that the person can have access to that information. You can tag the person and say, hey, at so-and-so, please make sure you come back to this variable and look at it carefully. So the platform is built as a collaborative environment. So that allows for properties like that to occur. Now here is for recoding. You have a set of buttons here that allow you to visualize, to rename. I may want to rename a variable. I may want to replace certain values. I may want to clone that variable into other variables. Recode. Recode is extremely important. So we're going to spend some moments looking at what recode means. Recode, as the name implies, you have R-E, and code, C-O-D. Whenever you say re, it means again. So rerun means run it again. Recycle means, well, let's recycle it again. Let's take it back to the very beginning and use it again. Recode means that we want to change the codes to something else. And that could mean that either we have, let's look at this variable, for example. We have, let's look at something small here. Descriptive. Let's look at this. So recode could mean either we have this value as 1 and 2, and we want to change those codes to something else. This is what we mean by the codes. The value here, 1 and 2, are what we call codes. Those are the codes of that variable. So recode means we want to change those codes to something else. It might mean we want to change it to 2 and 3, or 0 and 1. That's recode. Recode could also mean that maybe we want to change those codes maybe by collapsing some of them into something else. Now let's look at how recode works on the platform, right? Let's say we want to recode, let's say race, race. So let's say race, ethnicity. I'll come here, select it, and click on recode. Now, on the platform, we have two methods for doing anything. There's the easy way, and then there's the hard way. The easy way is supposed to be intuitive. Remember, this platform is designed for an 8-year-old child. So the question is, if we're designing and if we're trying to engineer a solution for an 8-year-old to recode, how would we do it? Well, the answer is simple. We have to do it in a way that is colorful and that is shiny and easy, right? So the assignment here is simple. How do we collapse, let's say, groups 4, 5, 6, and 7? Because this is a race ethnicity variable. If you look at in the report here, they have white, black, Hispanic, and other, right? The footnote for other says, okay, blacks, whites, and others are non-Hispanic, but every other individual that is not white, black, or Hispanic was put into other. So here we have 1 is white, 2 is black, and I know this because I'm very familiar with the data set. But you should never just guess what they are. This is bad practice. I'm giving you modeling bad behavior. You should always go to the data set, download it, and you're going to use the codebook. The codebook is the data dictionary, which you can now say, oh, 1 is white, and 2 is black, and 3 is Hispanic, and 4 is Asian. That is the best practice. So please do not follow my bad ways, okay? Always use the codebook. Wherever you see a data set, there must be a codebook that you should use to know what those values are. For the sake of just efficiency and speed, I will not go through that process, but you should absolutely do so. So if your plan is to write a manuscript with publicly available data, and on day 3, we're going to share some of those publicly available data, and your homework will be to actually try your hands at writing a manuscript like that. All right, let's continue. So I know that 1 is white, so I'm just going to relabel, edit label, and change the code. So this is also part of the code because I'm changing the code from 1 to white. So this is white. So I can type that value and confirm. 2 is black. I click on more actions, edit label, and change the code. Again, recode from 2 to black. 3 is Hispanic. Edit label, change it from 3 to Hispanic. Now, 4, 5, 6, and 7 are supposed to be combined together, and I can do it in one of many ways. If I'm feeling lazy, I can just select all of them and merge selected, or I can just choose to drag and drop. So here I'm just going to merge selected. So it merges all of them, 4 or 5 or 6 or 7 and so on and so forth. I can edit label and call this other. Now I can choose to say, all right, I don't want to do. Another option for me to do that is to just let me reset this. If I wanted to recode 4, 5, and 6, another option to do it is to drag and drop. Right? So when you drag and drop it, that's an easy way of merging them together. And that's how we just merge. It makes a vibration in your hand when you drag and drop. Again, remember I wanted to give a gamified experience. Kids love to play games. So it's like, how do you make analysis exciting? Well, you can do that by gamifying it, right? You introduce elements of playing a game. That's all it simply means. And for those of you who ever played Pro Evolution Soccer, when you almost miss a goal or you do something fantastic, you see the vibrator shakes in your hands, right? And that gives you that sense that, oh wow, something cool is happening or just happened. So we've tried to replicate some of those elements here. So when you drag and drop, there's a sound effect, there's a vibration. Now, I admit that could be very distracting in some environments. Imagine you're in the library and it keeps vibrating, or you don't want your battery to run down. Well, you can just simply come to color effects and sound effects and put all of them off, right? And that would prevent that from happening. So now we've recorded, so let's quickly edit the labels again. So this is white. This is black. This is Hispanic. And this is other. Oh, other here. Now, missing values. The beauty of this visual way of analyzing data is that it allows you to see everything that is happening, even things that you might take for granted if you were using the less visual method. So here you can see that, oh wow, I have 788 missing values. It's in your face. You can't run away from that, right? And so missing values are codified differently. You can't change the label. It's fixed like this. So you can choose to do whatever you want to missing. You can say, all right, I want to put other to missing. And note that the direction in which you move things matters. If I drag or missing and put into other, I am saying that take the missing and put them inside other. It's pretty obvious. However, the other direction means if I take other and try to put it here, I'm saying that carry the guys who are other and put them into missing so that they become missing. So that's the difference we want to understand, right? So the direction in which you drag and drop matters. Dragging missing into other means that I want the missing to be part of the order. Dragging order into missing means that, well, now there's no other group because the other has been merged into missing. As you can see, the sample size for missing has increased. However, if I want to drag the missing into Hispanic, in other words, I'm saying that this group is defined as Hispanic or missing, right? Quite different, So this is how you drag and that is how you recode variables, categorical variables on the Chisquares platform. Now, if you don't want to use the visual method, which is the drag and drop and the sound effects and all of that, you can use the classic method, right? But before I go into classic method, let me explain some of the other features you have here, which is the batch recode. Batch recode simply means that I want to take an action on one variable, and I want that action to be replicated across many other variables that look like it. Let's go back to that MMWR we're looking at. So let's say that I want to recode cigarettes and e-cigarettes and all these tobacco products, and all of them are similarly labeled. So if you look at this, let's go back to the data, and let's see when that batch recode is so helpful. If you look at cigarettes, just comparing cigarettes and cigars. So you can see each of them is coded as 1 and 2. But imagine I wanted to recode from 1 and 2 to 0 or 1, but I wanted to do that in batch mode, meaning many variables at a time. Obviously, the last thing I want to do is do it for one variable and then come back and do it for the next variable. I obviously want to do it for all of them at the same time. That's the value of batch recode. So in that case, I will simply go to my recode and select the variable of interest. In this case, let's say current cigarettes. And then I will say, well, I actually want to do a batch recode. So I'll select batch, and then it's going to tell me, okay, what are all the other variables that are in that batch that you want to apply that same change to? So I will say, all right, select current BDs and current dissolvables and snus and pipe. You can see the system will automatically filter to only variables that have the exact same pattern as the first one that was selected. And that's to prevent you from making a mistake. So it's extremely difficult to make a mistake on the Chisquares platform, because we have engineered methodology into the platform that prevents you from actually making that kind of mistakes. So here you can see all the variables that are selected are those that have an identical data structure to the first one that was selected. So here I can select all these variables, and when I'm done selecting, I can say, all right, here is my recode. I want to keep them as two categories. I don't have any interest in dragging 1 and 2. So the recode here is just changing the codes. I want to keep 1 as 1, but I want to change 2 as 0. So I just come here, more options, edit label, change 2 to 0, and confirm, right? So nothing else. That's all I wanted to do. It will automatically create new variables for you. And this is very important. Please do not replace your variables. If you have a data set, when you're recoding, try not to recode and replace. Because think about it, what if you made a mistake? But you just replaced the original variable you had. How do you recover it back? So on the Chisquares platform, whenever you recode, the platform automatically assigns a new name to the variable. So in this case, you see CBDs, it has appended _R to the new variable and all of them. And all I have to do is click on proceed, right? And the platform automatically has created all those new variables. So you can see that CCIGT, this is the original variable I created. So this is the original variable I created from. This was 1 and 2, but now it has created the recoded version, which is binary. So you can see even the icon here, this is 0 and 1. So now it has applied that change to all of them so that I can recode in batch mode, right? So that's one of the features of recode that you want to pay attention to. How do you recode in batch? And whenever you can, it's always a good idea to do things in batch because it reduces the likelihood for error, right? Errors always arise. The chance for error is always increased when you're just doing things repeatedly, right? And so that's why we have batch mode processing for most processes that you're going to work with. Recode may also simply mean appending a label to a variable. So let's say, for example, our variable gender, I think it's called sex. So you see sex here is 1 and 2. It's not very intuitive what 1 and 2 means. So I may choose to recode, not that I want to collapse groups, but that I just want to change the labels from numeric to add a label to them. So I can choose to say, all right, I'm going to edit the label, and instead of 1, I'm going to have female, right? That's another form of recording to make them more clear. The visual method on the Chi-Squares platform is, as the name implies, very visual. It picks up cues from the name. So in this case, it's female, so it has assigned a color of pink. So the colors are supposed to also help you with context, as the case might be. And then this is male, so I'm just going to assign male. So that when I'm doing my analysis, it helps me to be able to clearly distinguish between the genders. So here, I didn't do much to this variable, so I may choose to just replace it. And so to do that, I just click on replace original variable, and I'll click on proceed, right? So this is how you record. This is what recording is all about. Now, recording is not only for categorical variables. Sometimes you want to record variables that are continuous, right? Think of a variable like age. If you had age, from 0 to whatever, and you want to divide those ages into groups, right? That is also recode because you're trying to collapse. It's like having a big chunk of meat and you want to cook. Recode is simply saying that, well, we can divide that meat into smaller chunks, right? The question is, how do we know when we should recode? Well, you are the owner of a data set, so your judgment is important. So I might have age in, let's say, 0 to 100, and I say, okay, well, I want to divide it into two huge chunks of maybe 0 to 50 and 51 and above, right? That's judgment call. Or you can just do what every other person is doing. Maybe every other person is recording 0 to 20, 21 to 50, and so on. I think it's also safer that way, right? Because you don't have to explain to reviewers why you are suddenly the sheep who decided to go astray and do their own thing. So sometimes it's determined by the sample size, sometimes it's just your judgment call. But let's see how you can record a continuous variable. This is a variable we have as continuous. Let's see how that looks like. So again, we're going to select these options and click on recode. So the platform loads the variable. So for continuous variables, it loads the variables and tells you all the values from the minimum to the very maximum, right? And to record, let's say we want to split this variable into 2 groups, maybe from the minimum to, let's say, 3,200, and then 3,200 to and above. Well, all we need to do is just click somewhere that is around, or click anywhere really, but anywhere around that number. So that's where we have clicked, right? And so the platform will say, all right, that's where we understand that's where you want to divide the variable into 2 groups. Can you just confirm the exact number where you want to cut? So you can now put 3,200 and confirm. So the platform looks at the values that exist, and then it will cut that group like that, right? So this is how you can recode. So you can keep cutting and specifying where you want to cut, and the platform will keep making the cuts as needed. And then when you're done, you can assign names to them accordingly. So that's how you recode with continuous variables. Now, that's a visual way. For people who are more boring or who just prefer things the old school way, you don't have to use the visual method, right? Let's say we want to record, for example, race again. Let's go back to that race M and click on recode. But this time we don't like colors. We are very against color and against an easy life, and so we want to suffer. So instead of the visual method, you can select what we call a classic method. I would very much like to call it the boring method, but obviously you have to give something more professional. So the classic method allows you to be able to create categories in a way that you may be more used to. So here, for example, you create a new category. Let's say I want to categorize create the other group. So if value of race M is exactly equal to or contains any of 5, 4, 5, 6, 7, you select the options as needed. But again, right, that becomes quite I'm never a fan of this option, but I understand that some people would prefer that kind of option of recoding. But this is always the point I'm trying to make is I don't want to go down this rabbit hole, but this option is always here for you. You have all these operators here that you can then allow you to select whichever groups you want. But yeah, this option, the visual method is always the classic method is always here for you if you prefer the more old school way of doing things. So that's how you record, whether it's a categorical variable or a continuous variable. Now, another part of descriptive analysis is creating new variables, right? For example, if you go back to the MMWR report, they have a variable called any combustible tobacco use. And if you look at the footnotes here, it says any combustible tobacco product was defined as use of cigarettes, cigars, hookah, pipe, and or biddies at least one day in the past 30 days. So that is a composite variable. It's called a composite variable because we are creating it by combining multiple variables. As part of descriptive analysis, you have to know how to create composite variables. So let's look at how we can do that. In this case, we simply want to combine individuals who report that they've used any of those tobacco products into one category. You come to data processing, you come to create composite variable using conditions. So in other words, we're saying if this is so and so and so, then create so and so and so. That's what we mean by conditions. So create composite variable using conditions. I will stick with the visual method, please. So for those of you who want to suffer, you can always refer to the classic method. So we select the variables of interest, which were cigarettes, cigars, hookah, there was pipe, and there was biddies. So those are the variables we've selected here. Let's expand this so that we can see clearly. So the footnote said if you use this, so 1 is use, 0 is non-use. If you selected 1 here, or 1 here, or 1 here, or 1 here, or 1 here, then you are classified as a user of any combustible product. So we're going to manage this and say merge them. So merge means this or this or this or this. So this is what we have here. 1 or 1 or 1. So we've created that so we can drag it to this side to mean we are done with that category. And then every other person remaining, this is one of my favorite features on the platform. It makes creation of these variables such a breeze, right? If we're trying to write the code for this, it's going to be a bit complicated, right? But here, it allows you to create the first group, and then you can say all the other ones that are remaining, exclude missing, and create them. So it says, okay, assign all the remaining ones into one category, but while you're doing that, exclude missing. Why do we exclude missing? Because missing values, we are never sure this guy that is missing, was he a smoker or a non-smoker? We don't know for sure. So it's always, that's a standard approach we use in federal surveillance reports. Individuals with missing values are excluded as missing. So we're going to exclude missing here. So what that does is that we now have our categories here. We have 101 or 101, which we can edit the label as 1, and others, which we can edit the label as 0. And once we're done, we can then continue on our way. The platform automatically checks whether there's conflict, whether you have double counting. That's a lot of technical things behind the scene to make sure that the variable is created in a valid manner. We can assign a new name. Let's call it current combustible, and proceed to conflict resolution. It's checking if there are any problems. You don't have to do anything at that part. If there's no problem, it goes ahead to create a variable. So look at the variable we've created now. This is it here. It has 73 missing values, and we can visualize it, right? So this is how you create composite variables on the Chisquares platform. So to recap, we've looked at how to record our variables, and we've understood why we record. Record only applies to a single variable. It means we want to change its codes. Maybe because we want to make it more understandable, like sex, 1 and 2. It's not very clear, so we want to make it male and female. Or it could be that we want to collapse certain categories. Maybe we have, race, ethnicity, and we have all the other categories collapsed into other, as we saw. Those are different reasons why we may want to manage the data. So data management is a very, very important part of analysis. When you take your data set, you want to spend all the time you can on that part. If we're to put the whole activities involved in data analysis as a percentage, we can say that 60 to 70% of the heavy lifting is in the data management, which is like, recoding and renaming and creating composite variables and all of those things, right? Once you have done with all of those things, the analysis itself is pretty straightforward, right? So that's something we want to keep in mind, that never be in a rush to jump into the analysis itself, because that's the easy part, right? Analyzing, generating, prevalence estimates or regression, that's easy. The hard part is really getting it right with the things of this nature. Now, let's say that we now want to generate estimates, right? Let's go back to the MMWR. Let's say we're interested in saying, now that we have male and female, does the use of any combustible product differ between males and females? Because remember, in our lecture, we talked about bivariate. Bivariate means the girl is taller than the boy. There are two people involved, right? We're looking at, two groups, and we're seeing, is the height different? Sometimes when we're doing analysis, we want to compare groups, but we're not really exactly sure what kind of tests to use. And the solution is that you see people have on LinkedIn, you see there's never a shortage of posts about, here's a cheat sheet. If you have categorical and categorical, it's chi-square test, and then you're here memorizing, geez, if it's categorical and categorical, that's chi-square test. That's one of the things we've tried to solve. So as part of the analysis, you may want to do certain tests. You may want to compare two variables and see if they are different, but you may just not know what test to use. Well, that's what the analysis wizard is all about. The analysis wizard has many functions, but I'll just focus on one now, which is the statistical test checker. So let's say that we have two variables. Let's say we have sex and we have cigarette smoking. And the goal is, the question we're asking is, does cigarette smoking differ by gender? And we don't exactly know what test to use. Well, we just load our variables and we click on run, right? So what that does is that the platform will take those two variables and it will evaluate them on the kind of variables they are. And then it's going to tell you the kind of test you should run. And then it's going to run the test for you. And then it's going to interpret the results for you so that you can see clearly what the results are all about. So here we have the rationale. The rationale for selecting this test is that the chi-square test of independence evaluates whether there is a significant association between two categorical variables in a contingency table. And so it goes ahead to state the null hypothesis and all of that. And then it tells you the results. This is the table from the tests, and this is the result. So the chi-square test examined the association between sex and this variable, yielded a chi-square statistic of this and a p-value of this, indicating a statistically non-significant relationship. So in other words, cigarette smoking and sex do not differ significantly. There's no significant association between, those two variables. Or another way of saying is that the rates of smoking between males and females are not different significantly. So this is a very, very handy. It doesn't matter what variables you select, the platform will automatically detect them and then tell you what kind of test should be run, and then run the test for you and interpret it for you. So that saves you. Again, remember, the platform is designed for an 8-year-old child. There's no way an 8-year-old child will know, oh, this is the test you should do in these circumstances. But the bottom line is, how do we empower people so that you don't need a PhD in statistics before you can understand, you can get insights from your data, right? That's the problem we're trying to solve here with the Chisquares platform. So the analysis wizard is very helpful for those use cases. Now, let's go on a step further. Let's go back to our report. And remember, we were talking about weights and PSUs and strata. And now, if you're going to, again, if you're here to understand how to analyze data so you can write manuscripts and publish, well, it is very important that you know how to analyze complex survey data because, well, if you don't have the money to go and collect your own data, it makes sense to use publicly available data that is already prepared and ready for use. So let us see how that works out, right? But for context, let's first of all understand how the methodology works. Let's go back to the report here. So it tells us here that this data set, NYTS, is a cross-sectional voluntary school-based survey of US middle and high school students. A 3-stage cluster sampling procedure is used to generate a nationally representative sample of US students in grades 6 through 12. So that already tells us that there is cluster sampling involved, right? So that means that whenever you are analyzing the data, you must do certain things. First, data were weighted to account for the complex survey design and adjusted for non-response, right? This is extremely important. If you take a data set that is a complex survey data set and you do not account for the weighted design, your results are invalid. That is very, very important to note, right? You are getting results that are wrong, right? And so, if it's a complex survey data set, you must be able to account for the weights. And remember, why are we doing this again? The child does not look like a parent. We want to force this child to look like a parent so that we can make inferences from the child to the parent. That's what we're trying to do. It's as simple as that. So all of this process, all this story here is just telling you that, look, this child does not look like a parent. So here is the way we're going to force it to look like a parent. The analysis will have to account for the complex design. And so we calculate confidence intervals. And it says also that population estimates rounded down to the nearest 10,000 were computed. What does that mean in simple English? Let's look at the table that is generated here. If you look at the table here, estimated number of users. So here, for this product, you have among high school students, you have e-cigarette use. 9.9% population of the students used e-cigarettes, right? Among females. So among females, 9.9% of females use e-cigarettes. 13.3% of males reported e-cigarette use. That's how we interpret these results, right? And these are the confidence intervals. Now, the number here is telling us that in the US, this number in the whole population of the studied population of high school students, approximately 1.73 million used e-cigarettes, right? So this is giving us in terms of the actual number of students in the population, while this one is giving us as a percentage. So if you look at the report here, in 2017, 19.6% of high school students, an estimated 2.95 million users, reported current use of any tobacco product, including 9.2% or 1.38 million who currently used, combustible products, right? So for each product, you see they're reporting the percentage and a number of million users in terms of millions of thousands, right? The question is, how are they getting those numbers? How do they get the 1.38 million? Okay, let me tell you how they are not getting it. You might think that, oh, all we have to do is take this 9.2% and multiply by the number of students in that population. That's a wrong way of doing it. And you're not going to get this number at all. The reason why that's the wrong way of doing it is that you are taking the 9.2 and multiplying by all students or all children who are who are at high school age. But that something is supposed to be a particular way doesn't mean that it is that way. The survey, the NYTS survey, has what we call a sampling frame. A sampling frame is like, it's like the box from which we sampled. That box from which we sampled is not necessarily everybody that should be there. So it's not everybody that should be in that box that is in that box. Why? Well, how about kids who are supposed to be in school on that day but are truants? Well, they're not in school, so they're not necessarily captured, right? Truants. What about kids who are dropouts? Well, they're of high school age but are not there, right? What about kids who are high school but that are not in schools that are captured by NYTS? They're not in that sampling frame either. What about kids of US military who are in high school but are in some maybe US military installation in some country? Well, they're not in that survey either. So for those reasons, we can't just take this number and multiply it by the number of students who are of that age or who are in that high school level. That would give us a wrong answer. We don't do it that way. So part of analyzing complex survey data is also being able to generate all of these things and knowing how to work them. Again, you don't have to know the theory, right? On the Chisquares platform, it's been designed in such a way that it's super, super easy for you to do that. And I'm going to explain that in a minute. So we should be able to do this. We should be able to, part of descriptive analysis means, one, you should be able to calculate prevalence estimates with their confidence intervals. Clearly, that should not be a problem for you. This is what is in this table. Number one. Number two, if required, you should be able to generate counts. And this is very important from the perspective of media communication. The media loves these numbers, right? Media, whenever I was communicating with the media, we always give them that, we always throw them this kind of numbers. They love it. They will say, oh, 1.73 million. I mean, there's a ring to it. Like, it sounds a lot more sexier than just saying, oh, there were 5.5%. That's a bit dry. So again, when we're communicating with media, it's always a good idea to use, population counts, because it makes the estimates come to life. And again, when we're speaking to policymakers, a policymaker may say, oh, well, how many people use, let's look at this, a product here, like pipe. Oh, just 0.5%, that's a small number. But if you told them that, oh, there are actually 120,000 US students and high school students who use pipe, they're like, oh, wow, that's a huge number, right? So that's the reason why we use weighted counts, to communicate the same message, just a different way for people who may not necessarily find percentages quite impactful. And that is the reason why we use weighted counts. So the objective of you analyzing survey data like this is that, one, know how to calculate prevalence with confidence intervals. Number two, know how to be able to generate counts like this. Number three, you should be able to tell a story, but tell a reliable story. Not all stories are reliable. And that is why you have to look for estimates that are not reliable and not share them. I mean, what's the point of sharing an estimate with me that may be true or may be false? I'm not sure, right? I don't know what to do with it. So in general, we always suppress estimates that are not reliable. So if you look at this estimate here, for smokeless tobacco, you see this commented out, and I see a footnote that says, data are statistically unreliable because sample size was less than 50, or relative standard error was more than 30%, or 0.3 as a proportion, right? That is extremely important. The relative standard error is calculated as a standard error, divided by the mean. So we'll take the mean and divide by standard error and see how big is it? And again, you shouldn't worry about the calculation of it manually. You should just be familiar with the cutoffs that are deemed as reliable. So all you need to know is that 30%, anything above that is not so good. And then you should know how to implement that in your work. This is applied epidemiology. So we're not asking you to know the theory, but you should know at what cutoff you start having problems. And the cutoff we generally use is 30%, right? So that's something you want to keep in mind. We're going to show you how to do this in a minute. And so at minimum, those are some of the things that you should be able to do to be able to communicate clearly your findings. So let us see how that works out. So let's go back to the platform and let's see how we can generate those estimates. But first, we need to set our analysis to complex survey mode. We have to account for those variables in our analysis. So we'll come here. On the analysis mode, you can see it's unweighted now. That means that the current analysis does not account for weights. So to change this, we just simply click this button here and says apply weighted analysis. We choose the weight variable. In this case, this is the final weight. The platform automatically filters out any variable that is not even possible to serve as a weight variable. There are very specific requirements for variables that can be used as weights. So the platform applies intelligence to all the variables you have, and any variable that does not even remotely meet that criteria is filtered. So what does that mean? It means that you will not see all your variables here. So you shouldn't be wondering, oh, where did all my variables go to? Well, the platform has filtered them out because they do not even meet the theoretical definition of a weight variable. So we've selected a weight variable. We'll select our PSU variable. We can search. This is our PSU variable. And we'll select our stratum variable. And we save, and that's it. That's all we need to do to set our analysis to survey mode. From now henceforth, anything you do, the platform will automatically account for that complex survey mode, right? So let's see some of the analysis. Let's see how that goes. Let's come to estimate. So data processing is all about processing your data. Find and replace and recode and create composite variable and all the million things you need to do to get your data to a form where you can analyze it properly. Estimate is, as the name implies, generating estimates, right? Whether they are estimates of a population characteristics or regression analysis and so on and so forth. So here, I want to generate prevalence. And I want the prevalence of, let's say, current cigar, and let's select the other variables that were there. Hookah and pipe and biddies and current combustible. Now, let me throw in a variable that does not meet the requirements. For you to estimate prevalence estimates on the platform, the variables must be coded as 0 or 1. So they must be binary. So the question is, what happens when your variable is not binary? Well, the platform will still allow you to select it. So let me select a variable like that. Let's say, let me look for a variable that is not like that remotely. Solvables. Okay, let's use this one. Roll your own cigarettes. It's coded as 1 and 2. So we'll do that. Let me minimize my screen a bit. I'll say done selecting. So here it has automatically flagged this variable that no, this variable is not in the format we would like it to be. So you have to recode it to continue, all right? So that's one of the things we've tried to build, into the platform in its engineering, is such that there's a level of seamlessness. Seamlessness in this case means that if I am running a procedure and I come into problems, don't tell me to go and figure it out and then come back and start all over again. Give me an opportunity to correct the problem on the fly so I can just correct it seamlessly and just move on with my life without having to restart all over again. So in this case, you have a problem. You can either say, oh, well, I just want to remove this variable or I want to recode it, all right? So in this case, it says, all right, the variable has to be recorded as 1 and 0. So this is a box for 0. This is a box for 1. So drag the one item that is meant for 1. So I'll drag this here, and I'll drag this here, and problem solved. I can now, I can choose to replace the original variable name, or I can say, call it 2, and I can, get on my way like that, right? So proceed. So now all my variables meet the requirements, and I can proceed with my analysis. So these are the outcome variables we had here. So this is how you select them. Again, the platform allows you to select any variable for the outcome, and if it's not in the right form, it's going to tell you and help you to record it on the fly so you can continue with your work. All right. Next, you have stratification variables. Stratification variables are those variables that are strata. We're stratifying this prevalence by sex and race ethnicity, right? So this sex and race ethnicity in this case are our stratification variables because the results are presented within strata of sex, male and female and white and black. So here we're going to select our stratification variables as sex and race. I'm not sure whether we recorded race, and I think I recorded it in such a way that it was a bit nonsensical. So I'm just going to select sex now, but you can select as many variables as you want. And then if you're analyzing trends over time, you can then select your trend variable. But here we're not analyzing trends, so we're going to leave that for tomorrow. But yeah, if you have a time variable, you want to see how does the prevalence of cigarette smoking by sex vary over time? That's where you select this indicator. We're going to have an example within our workshop before it ends. Now here you can choose to also compute weighted population counts. So you see, this option is presented to us here. And this is the option here to calculate count, right? So we can choose to select this box here, and the platform will automatically generate that for us along with all the other analysis. You can also choose a desired rounding, right? These are the different ways you can round it. Remember that what all that is doing is that it's adding the sum of the weights for each group. And so you can choose, this is one area where you don't want to be too precise. This is, the MMWR gives a very good example for how to do this. If you can look at the numbers here, see how they're all rounded up. Imagine how absurd it would be if they said that the total number of hookah smokers is 483,256.1. It's like, okay, that's an awfully detailed and awfully precise number. Like, were you there counting them? No, you weren't counting them. If you weren't counting them, why are you so precise, right? So we try to avoid that in research when we're using count. So we try to round to a level that is not very precise. That's a way of showing humility, that we acknowledge that we were not there counting these people. We acknowledge that we're just using weight. And so we know that there could be mistakes in our weighting algorithms. And so we will be humble and not be too precise. That's all you're doing, right? And so you want to always do that when you're using weights. Don't be too precise. And the MMWR sets a very good example here. It says that population estimates were rounded down to the nearest 10,000, right? That's what it did. So we're going to do that exactly too. We're going to round to the nearest 10,000. Again, the purpose is that we want to generate the numbers, but we don't want them to be too precise because that is not a mark of humility at all. Now, you can choose to analyze the data among the entire data sets, or you can choose to analyze it among a subset, right? In this case, the MMWR analyzed their results among, let's say, high school students separately from middle school students. So this is what we call subset analysis or subgroup analysis. Overall analysis will have been one where we analyze data for high school students and middle school students all together, right? That's not what they did here. If you look at here, all this part up here is among high school students, and all this part below is among middle school students. Now, must you do it that way? No. You can say, oh, my own analysis, I am just interested in the whole population, and then I can choose to say, now, in the whole population, I'm going to break down my results by sex, race, and school level. So in that case, school level just becomes a tabulation variable like sex and race, but this is not what they did. Now, which method is better? There's no such thing as one method is better than the other. It depends on what kind of story you want to tell. So remember we said that Lego blocks we had at the beginning of a class, The story you tell from the data is a function of what kind of story you want to tell. So all of those things are within your power as a researcher to choose what kind of story you want to tell, right? So, so in this case, let's just do what it did. Let's say we want to do a subset analysis. I want to define, let's say, high school students. So we'll go to the variable that is school type. And if school type is exactly equal to, I believe it's one. I can't remember exact, but for the sake of this demonstration, let's just say 1. Let's check the sample size for that group. 7,552. Okay, let me, I think it's 2. I think so you can always check the sample size indicator there allows you to see how many people are there. If you had a sense of the sample size in that group, like I know that high school students, I've worked with this survey for a long time. I know that high school students are always more than middle school students. So even though I didn't know what 1 or 2 was, I just checked the sample size. The first time it was telling me 7,000. I'm like, okay, well, what about the second one? Now I know that this is definitely high school students because they're usually sampled more in NYTS than middle school students. So, but please, this is not, you should always check the code book. Again, I'm modeling bad behavior here. Always go to your, while it's modeling, always go to the code book, and we'll go to that in a minute. Always go to your code book and check to ensure that you've selected the right parameter. Now, when you are analyzing, you can also set some preferences. You can choose the number of decimal places. You can choose whether to suppress unreliable estimates or not, right? Remember that in the MMWR, we had some prevalence estimates that were not reliable and like they were suppressed here and many other places. You can, it's, if you're working with survey data sets, you always want to do that because why would you want to communicate results that are not reliable to your audience? So let's go back here. Let's say, yes, the preference under preferences, we definitely want to suppress unreliable estimates. When you check this box, you now have the option to select the RSE threshold. And if you look at the hint here, the hint says the RSE threshold is calculated as the standard error divided by the proportion, and it measures estimate reliability. And values above 30% in general, what does that mean? It means that it's not as if it's written in stone. But it means that in practice, that's the number we use most of the time. But the platform, of course, the platform will not force you to set which option you want. You can choose any marker. We've only restricted you to options that are considered reasonable in scientific research and surveillance. Anything beyond those boundaries is unreasonable. Why? Because if you set a relative standard error threshold of more than 60%, well, it's like an open door. It's letting everybody pass. So what's the point of showing you something that doesn't make sense? All right. So that's the philosophy of the platform, right? The thresholds that are set for you to select from are things that are reasonable and within the standards of practice. So for now, I'm just going to use what the MMWR did, and you have the option to present your estimates as either percentages with confidence intervals or percentage with standard error. Either of these are really fine, right? You want to use percentage with standard error when you have a wide table. Look at this, for example. When you have, why is estimating? Let's look at this here. When you have a table like this is pretty wide. Sometimes you have a very, very massive table. And if you have confidence intervals, this is 1, 2, 3, 4, 5, 6 or so characters wider. With standard errors, you just have two things. So these are just some tricks to writing. Standard errors and confidence intervals are exchangeable, but that choice is whether you have a lot of items in the column. But these are things that you have within your choice to select. It's not a requirement that you show 95% the percentages with confidence intervals. You can choose to show the percentages with standard errors. Those are actually exchangeable. The standard error is perfectly exchangeable with the confidence interval. If I know the standard error, obviously I can calculate the confidence interval. So those choices are up to you. But anyway, the platform has analyzed the results. So this is our output here. We have the products we analyzed: cigarettes, cigar, hookah, pipe, and so on and so forth, displayed here. And then here we have the results by sex, female and male. And then you have the corresponding estimates, right? So that's the table that is generated. The platform also gives you a plot of the data visualization. They say a picture is worth 1,000 words. So you have a picture that shows you what it looks like. And then you have the text for the results as well. And so this allows you to be able to visualize it accordingly in terms of the text, right? So you have the prevalence estimates. It writes out the report for you based on standard scientific convention. So, I mean, it was there observing while you were picking the variable. So it kept track of that. So this has nothing to do with AI. As you can see here, it says no AI is used for any part of analysis on the Chisquares platform. So it's just how to make analysis smarter, right? Obviously, the platform was there when you were selecting the variables, and so it tracked all you did. It can see obviously the results that you have generated, and all of that, and that's on the basis of that it writes the results. And so the results here shows that this is the text. It summarizes the main findings, right? And this allows researchers to shift their focus from worrying about technical execution, like, oh, geez, how do I calculate relative standard error? Well, you don't have to calculate it. You don't manually. You only have to know how to interpret it. You have to know what threshold is reasonable and whether you want to apply that threshold. You want to know whether or not you want to show estimates with confidence intervals. The platform also, as it writes the results, it includes an indication of which differences were significant. So as it's writing the results, it's actually performing statistical testing to see whether groups were significantly different or not. So here, for example, it says, as evident from table 1 and figure 1, prevalence in the study population was as follows by the outcome. This is for roll your own cigarettes for the different products. And then it provides the results by subgroups. This is what we call stratified prevalence. Stratified means we're breaking it by subgroups, right? So it's saying that significant differences in cigar, pipe, and roll your own were seen for sex, and so on and so forth. So it writes out the result for you, so that if you're writing a manuscript, if your goal is to write a manuscript, all you need to do is just take the results and push them to your manuscript. So in this case, if I were writing a manuscript on tobacco use prevalence, all I would do is come here and say, just push the results to my manuscript. So let me push those results. I can create a new manuscript since I don't have one here. It's an academic manuscript. And I would put the title as Prevalence of Tobacco Use Behaviors Among Youth. And the aim, let me ask AI to generate the aim for me. I can type it myself. All right, so I can just select any set of aims. And once I'm ready with that, let me move this out of the way, start writing. So that's the paper I've selected. I'm going to push the results there now. So it's pushed the results to my manuscript. Now I can view the document. So it's taken the analysis, written all the results, and now it's brought them to the document that's created for me on the Chisquares platform. Again, remember the platform is supposed to be an ecosystem, an end-to-end ecosystem for research. So what that means in simple terms is that I shouldn't have to say, oh, geez, I'm done with analyzing this, and now I have to go to Microsoft Word and write it. It's like, why can't the platform do that for me? So that's what it does, literally. And so these are the results that have been pushed here. We have tables, unresolved tables that need to be tidied up. Let's tidy them up. So this is our tables here, and our figures down here as well. So if we look at the prevalence of current cigarette smoking, remember we did a statistical test that showed no difference. You can see why there was no difference. Among females, it's 7.5. Among males, it's 7.6, right? That clearly shows just by eyeballing, you can tell that, there's no difference. Let's go back to the MMWR to confirm that. Cigarette smoking, female 7.5, male 7.6. Exactly the same result we got from our analysis, right? So again, the platform does all of that analysis for you and pushes that. Again, none of this involves AI, right? This is just smart engineering to enable us to be able to focus on insights than, worry about the mechanics of, oh, geez, how do I do this? And also to prevent you from making mistakes, right? You're way more likely to make a mistake when you are trying to, do things manually that way. So this way you focus on insights and interpretation of the results and not on the manual aspects of the work. All right, so here we have the population counts in terms of, total number of users. So for example, for cigarettes, we have approximately 1.12 million approximately of youth who reported cigarette smoking in the overall population, right? So when we compare that here, that's the exact same number we see here. 11200000, right? Let's go back there. 1120, so exact same number, right? So so that's how you calculate this thing. So the Chisquares platform allows you to, for whether it's descriptive analysis. Of course, our session today is focused on just descriptive analysis, means and medians and percentages. All of those things are completely automated so that you can then focus on just how do you interpret this? What's the value here, right? And over the next 2 days, we're going to be focusing on the developing the evidence and writing the manuscript. For now, when you push your results, one of the things I want to highlight here is that the platform pushes them in what we call packet IDs. So they're pushed in parcels. What that means is that you can do many analysis and keep pushing them. The platform automatically reorders the contents. That's why you have different boxes here like this, right? It reorders the contents. And when you are done with everything, you can just click here to polish the document. We're going to do all of that on the 3rd day. But this is to tell you that this is not some AI at work. It's just smart engineering that knows that, okay, each push is identified by a particular ID based on where it's supposed to be and how manuscripts are written. In general, we know that scientific writing, univariate comes before bivariate, and bivariate comes before multivariable or multivariate, right? That's just the order in which we write science. And so that's exactly what the platform does as well. And so that's how you can switch back to analysis and go back to, oops, I went back to the wrong data set. But yeah, we can switch back to analysis and proceed, right? So you can definitely play with, how to generate mean estimates, because descriptive analysis includes population characteristics, meaning who is in our population, generation of mean estimates or prevalence, right? Or just looking at, what's the distribution and all of those things. All of those things are part of descriptive analysis, which we need to understand. At the very least, as researchers, we need to get that part down, because if we're going to describe things, then that's the staple, that's the foundation of every other research. Sometimes we get carried away by fancy terminology, but that forms the bedrock of whatever research we do. Now, if you're just interested in the basic descriptive analysis without a further deep dive into what they mean, the platform provides here this descriptive statistics report, which is simply a summary of or an analysis of everything in your data set. So it takes the whole data set, analyzes it based on the type of variable it is, and you can then download the report as a PDF, or you can view it online. But in general, we don't just do high-level summaries, right? We always want to deep dive into what the variables mean, but this is also provided for you to account for that. Analysis history allows you to look at the analysis you've done. So let me go back to our day 1 project. So that way you can look at what has been done through the analysis history. Preview allows you to be able to look at your data set. I may want to see my data set in spreadsheet mode, right? And so this allows you to see that data set clearly. I may want to make edits to it, so you can edit your data set. In general, you want to be very careful with making edits to an existing data set because you want the data to have integrity. So unless you are pretty sure about what you're editing, it's best not to do manual edits this way. But anyway, in case you need to do it, the platform allows you the capability to edit your data set manually. So in a nutshell, this is what descriptive analysis is all about. It's about, how do we describe the population? Whether it's a univariate analysis, whether it's a bivariate analysis, it's about telling a story, right, with the data and having to change the shape of the data to do that. We may want to recode a variable. We may want to append data sets together. And that's also provided for you here, right? Append means, so if you have data set actions here, you have, let's come here, combine data sets. Why might we want to combine data sets? Well, let's say we have an outcome that is very rare, and we want to increase samples or pool data sets across many years to have a larger sample size. That's where combined data sets come. There are two ways of combining data sets. You either stack them on top of each other so that they're taller, right? We call that append. Or you put them side by side so they are wider. So one makes the data set taller, that makes it wider, right? So think of the example where we said you want to combine data sets from many years so that you have more rows. That's an example of append. So we append data sets to make it because the individuals in the different rows are different. The guys who were surveyed in 2011 are different from those in 2012. But we just want to put them all together so that our sample size is increased. That's append. So when you say you want to combine data sets, the platform will say, what kind of combination do you want? Do you want to select append, which is different individuals in the different data sets? Or do you want to merge? So let's try append. You say you want to append data sets. This is the data set we have currently. This is the current data set, right? So it says, okay, do you want to upload the additional data sets you want? So we can now select the different data sets. That's the data set I want to append. I import it, and I can now append. You can select many data sets. There's no limit to the number of files that you can append. So you can have, well, in theory, there's always a limit, right? Or in practice, there's always a limit, but at least theoretically, we've engineered the system in such a way that there is no limit to the number of files. Of course, you have to worry about storage limits at some point, but you can append as many data sets as you need. So once you click on append, the platform will then take the data sets and then append them accordingly. The same thing applies to merge. Merge is so now it's finished with the append procedure. And if you look at the sample size here, that has doubled about, right? I had 35,700, I have 35,744 people now, but I had about 17,000 approximately then. So that's what append means. We take a data set and we put it together on top of each other so that the number of rows increases. I may now want to change the name to appended, or whatever I want. And yeah, so to rename a data set, just click inside and rename it. So that's how you append. When you append the data set, you want to be careful to ensure that like this variable here, the append source that, in this case, these are the individuals we have from data set 1 and data set 2. The platform automatically creates an indicator that tells us which individuals came from this data set versus from that data set, so that you won't be confused. Because you who did the appending may come back and be asking, oh, geez, which person is in which file? That is done for you automatically. right? So that's the first part of combining data sets, where we append one on top of the other to give us more rows. The second part of combined data sets is merge. Merge is if we have information from the same individuals. So imagine that you did a survey where you asked the same individuals, right? Questions on different days of a week, and each data set has a unique ID for the person. Maybe the unique ID is their phone number or their email, but that's a unique ID that is special to each individual. Merge simply means that I want to put the data sets for the 5 days together. Remember that each person was repeated across time. So merge is simply saying that you want to do that exact procedure where you can then upload a file, you select, the unique ID, and the system will merge. I don't have a file like that, but that's how you do that procedure. Why do we merge, or why do we append? Well, because we're trying to tell a story. We append because we want to tell a story, and we feel that the volume of our data set is too small, so we want to increase the volume so that the volume is what we call precision, right? If your data set has many people, then your study has high precision. It has nothing to do with validity. Let's be clear. Validity and precision are completely different things. Precision is saying, oh, the volume is loud, right? The volume may be loud, but the music sucks. That doesn't make it enjoyable, right? So if the music quality is the validity, then its volume is precision, right? So if you have a data set that is large, you're going to have precise estimates. And what do we mean by precise estimates? We mean that the confidence intervals are going to be very narrow, right? Validity simply means, is it the truth? Is it accurate, right? So that's the reason why we append, so that we can tell a story with many people in a way that the volume is loud. I'm using volume is loud in quotes because so that we can have precise estimates that makes sense, and that's why we do those things, right? The reason why we merge is because I may have the data set A may have some information, but the other missing information is in data set B for that same individual, and I need to somehow link them together so that I have the full information for all of them. That's why we merge, that's why we append, so that we can tell a story the way we want to tell it. The test here is part of statistical testing, and this is just in case you know what you're doing. So remember, there are two types of individuals: people who know what they're doing and people who don't know what they're doing. If you don't know what you're doing, you should go to Analysis Wizard and go to Test Checker and say, here are the variables I want to test. Can you just perform the test for me? That's if you don't know what you're doing. If you know what you're doing, you can just go to test and say, all right, I know that I have to use a Mann-Whitney U test, or I know I have to use a Wilcoxon sign rank test. You select the test and you run it, right? That is if you know what you're doing. If you don't know what you're doing, you will ultimately still get to this position. The platform will still take you to that exact same test if you simply went through this route of statistical test checker and said, all right, look, I am humble here. I don't know what I'm doing. Just help me out. You will still get that exact same things. But in general, when you do procedures, the platform takes account of all of those things and it runs the test. And that's why the mode of operation on the platform is a partnership. It's a partnership because you supply the context for any analysis we're doing. Let's say even for things that we have already guessed the variable type. Let's say you want to, do a population characteristics. We say, all right, select the variables that make up the characteristics. You select this. We don't presume that we know the final variable, even though we have a good idea of what it is. We still ask you, please, just confirm the variable type for us one more time, right? That is if you have not confirmed it before. That's so that we engineer scientific products in such a way that we build in validity and also context, because sometimes it's impossible to know whether 1 and 2 represents a numeric variable or whether it's just a categorical variable. We can't tell. It's impossible to tell with an algorithm. It's only you. Imagine you coded your variable as male, as 1 for males and 2 for females, and the platform imagines that it's just because it's numbers that the variable is numeric. That would be a very false and a very grave mistake to make. And that's why for every single procedure of this nature, we've already classified this as a discrete variable, but we ask you to confirm that way it's a partnership. So it's not just that the computer is just running around and doing its own thing, right? Because that will be pretty dangerous. And so as you practice with descriptive analysis, I'm going to give you homework to do with the data set, because we need to get you practicing how to analyze complex survey data. So after this session, we're going to post homework. The homework will be for you to replicate this table. You can choose whether you want to do it for middle school students or for high school students. But your job is to create those variables to the extent possible, that the ones that you can. Some require you thinking around the box. For example, this variable here, people who use 2 or more products. Let me just show you how to do that, so that in case you're doing it, you can. 2 or more products. If I were doing it, I will come to data processing. I'll come to arithmetic transformations, right? In this case, and say I want multiple variables. In other words, we want to do arithmetic, 1 + 1 + 1. So I want to do on, let's say, I'm just going to select a few variables to demonstrate what I mean. And I want to combine them, because the variable is how many people use 2 or more products. So that means that we have to create a tally or a sum of products that all people use. So if we recorded the variables as 0 and 1, and if we took their sum, if you have a sum of 7, that means you use 7 products. All right. So actually, let me just do it properly. So we have electronic cigarettes use and hookah, and I'll just select some examples: cigar and, let's see, pipe and dissolvables. So let me do that. And we want the sum. This checkbox is very important. The checkbox says, now, when you're doing descriptive analysis, it is very important for you to pay attention to issues of missing values. How are we handling missing values? It's something I want you to be very conscious about. And that's why on the Chisquares platform, we always put this in your face. You cannot avoid it, because sometimes I don't think people think enough about missing values and the implications that has on the analysis. So we put it right there in your face. You can't miss it. So the question is, if we're adding across rows, what should we do to rows that have missing information, right? That's what it's asking. So let me show you what I mean. Let me illustrate that quickly with a simple visualization. And that's very important for you to pay attention to, right? Because let's say I have these scenarios: variable A, variable B, and variable C. At some point, you're going to run into this decision and say, how am I going to handle this? Individual A or individual 1, let me call him is alpha, beta, and Charlie. So he has 1, 1, 1. He has 1. He has missing. He has 1. He has missing, missing, missing. Let's put delta here. Yes. 0, 0, 0, 0, 0 missing. All right. Now, at some point in your analysis of categorical data or descriptive analysis, you will have to contend with this issue. So I want to create a measure of, okay, I want to create the sum of tobacco products used. This guy has used product A, B, and C. This one is obvious. There's no problem with this one. All of us agree that his tobacco product use is 3. Now, what of this guy? We know he has reported 1 here, missing here, and 1 here. We know that he has used at least 2 products. Well, we can say there are 2 ways to go about that. We can say, well, we don't know about the 3rd product. We can either give him missing value, or we give him 2. And we're going to debate about each of these approaches in a minute. But this is something that we all have to pay very, very close attention to, because it forms the basis of the results we get from analysis, even if we have not actively considered the implications when we are working with the data. The guy who has missing, missing, it's obvious that he has a value of missing here. Few will argue that. Now, what of this guy who has 0, 0 missing? The question is, what do we do with him? Now, this is where we have a problem. This guy and this guy are similar, but so different. In the first place, we have 2 1s and 1 missing. And we all happily shouted, let's give him a value of 2, right? And that is reasonable. Now, for this guy, it's the opposite. He has 2 values of 0 and the third. So should we give him should his value be 0? But if we give him 0, what if he actually used a tobacco product and he has a value of 1 for this point here? So we have a problem now, right? We have a problem of misclassification now. Because if he was actually a tobacco user here and we gave him 0, we have run into problems. So there are 2 ways to go about this. You can say, well, we're just going to create a sum for only people who have full information on all products. And anybody who is missing, we'll just classify them as missing. So in this case, that would mean we're going to have 3 here. We're going to have, if we're going to say only missing, all or none, then we're going to have 3 here. This one is missing, so we're going to have missing because it's all or none. This is missing, and this is missing. Well, and then we can have the approach that we can say, oh, let's be efficient. If we have data for somebody, let's at least use it, right? So here we're going to have 3 here. We'll have 2 here. We'll have missing here because it doesn't have any information. And here we're going to have 0 and say, well, we know there's a chance of misclassification, but now this is a battle between validity versus precision. This is what we call in epidemiology the trade-offs between validity and precision. Validity means a more valid approach would be to say, let's use this one, so that if you don't have full information, we're going to kick you out. But that is also very wasteful, because imagine we wasted this information for these 2 guys, even though they had most information, but we simply could not use them because of this sanctimonious approach, right? Sanctimonious in quotes, right? So this is one of the struggles you're going to have to deal with between validity and precision. It is a battle you're going to contemplate all your career about what should we prioritize? Should we prioritize validity or should we prioritize precision, right? And that's exactly what this stuff is doing here. The checkbox here says, checking the box indicates that if any single item in a row is missing, the entire row is treated as missing and excluded from analysis. Prioritizing validity, which is all or none rule. Unchecking the box means that if at least one item in a row is present, the row must be included in analysis, prioritizing precision. Which one is correct? Well, these are tough decisions that you have to make. Nobody's going to tell you which one is right or wrong. You just make a decision that you feel is right in your context, and then you defend it, right? So that's what we're going to do. So here, I want us to be efficient. So I'm going to uncheck the box and, create a variable called polytobacco and transform. So that creates a sum for all the individuals here. So now you can see here that I have a sum for all of the products. 0, 1, 2. So 0 means individuals who reported 0 for all products. Then, if I wanted to create this variable, then I can now recode and say, if you use 2 or more, I will assign you a value of 1. If you use 0 or 1, I will assign you a value of 0. So let's quickly recode this. Let me recode. So in other words, we're saying if you use everything except 0 and 1, of course, missing. So all these guys, if you use 2, 3, 4, 5, will merge. And that's our polytobacco group. And let's call this, edit the label to 1. And then 0 and 1 together as 0. So that's how you create a variable like that, like this one. 2 or more products. You first of all create the tally for the more products you used, right? And then you now recode. All right, so we're going to stop here. I'm going to share the homework on our LinkedIn profile, and so you can attempt it. I think it'd be good practice for you to attempt how to, because this is if you're going to work in public health, or if you want to really expand your career, you have to get very comfortable with analyzing complex survey data. And I'm not talking about regressions and all of those things, all the fancy stuff. I'm talking about the foundational things, the fundamentals of it, right? So your job is to create a table like this for either high school students only, or middle school students, or both, whichever, right? And account for suppression of unreliable estimates, generate population counts, set the data to complex survey, supply all of those things, right? That way you gradually build your confidence towards complex survey analysis. All right, enough of talking on my end. If you have any questions, I'm happy to take them now.
Thank you, Prof. Ali Nasir, I see you have a question. I wonder if you can raise your hand because the question is quite long, so I can let you speak. Otherwise, I can try to read. Respected Professor, thanks a lot for a wonderful session as usual. I have two questions. Number one, why is it important to distinguish between ratio and interval data in analysis? How does identifying the correct data category, in brackets, ratio versus interval, influence the choice of analytical methods and interpretation of results?
That's a very, very good question. Since both of them are continuous, I'll just give, because it affects the kind of analysis you can do, right? Let's paint a scenario. Let's say that you are doing a regression analysis on a variable that is continuous, and you realize that, geez, this variable is skewed, is right skewed, right? And I want to do a transformation. I want to do let's say, log transformation, so that it meets some underlying, assumptions of regression. Well, here is the kicker. You can do that with one of the variables, but not the other. You can't do a log. I mean, you can do it. It just doesn't make theoretical sense. You cannot use log transformation on an interval that has negative values, because the underlying assumption is that the variables have non-zero. They are not negative. They are positive values that are above zero. So you see that even in that simple example, you see how we are running into roadblocks, because one variable is sub-zero, has negative values, and the other doesn't, right? So for those reasons, it's important for us to know the distinction, and when we're dealing with variables that potentially could be negative. It's that negativity particularly that has great impact on that. And even for count data, the same thing applies, right? All count data are intervals, but not all intervals are counts. And that is because whenever we have negative values, even if they are discrete, they're no longer counts. That means that it doesn't make sense to apply certain statistical procedures like Poisson regression, because here you're dealing with counts which cannot be negative. So it's important for us, in a nutshell, because that awareness directly impacts on the kind of analysis that we can perform and whether they are valid or not valid.
Thank you. Please unmute yourself, Ali.
Respected Professor, thank you so much. I think this platform is more than, 5 years old, Chilton, rather than 8 years old. So thank you so much for this. So my second question, Prof, regarding, for example, if I have a population of 1,000 cash distribution beneficiaries, and I selected a simple random sample of 350 individuals, is it still appropriate to use the weighted data analysis?
So we use weights when you have, the key word here is differential selection probabilities. The key word is differential, right? If selection probabilities are not differential, then there's no point using weights. Well, let me take that back. Let me give you some nuance. All right, there's some nuance that I want to generalize, so that all right. First of all, let's acknowledge that we want to focus on the word differential, right? So you only, in the scenario you painted, you use a simple random sample which means everybody has the same probability of being selected, right? So in that case, there is no need for design weights. Take note that I'm using very precise terms now, right? There's no need for design weights because we use design weights to correct for differential selection probabilities. In this case, if the probability was 0.5, well, 1 over 0.5 is everybody has the same weight, right? Which is 2. 1 over 2, its inverse is 2. So that means everybody has the same weight. And remember we said if everybody has the same value of anything, then that is no longer a variable because it does not vary. So if we use simple random sampling, if we use systematic sampling, if we use a proportional cluster sampling, then we don't need weights per se because everybody has the exact same selection probability. However, I'm going to add that caveat, we may still need weights if the issue is not necessarily with the selection probabilities, but with non-response. So those are two things we're always trying to correct for. One is where your selection probability is the same. The other is did groups respond the same, right? So one is focusing on our action. The other is focusing on your own actions. So one weight deals with what we did or did not do. The other weight deals with what you as a participant did or did not do, right? What we did is the base weights or the design weights. That's what we correct for our own sins. How we correct for your own sins is the non-response weights. So when we now take those two weights, our sins and your sins, we now have to combine them together to give you a final weight. That's why you look at all of those data sets, they always say final weight. The reason why that is final is there is because there are other weights that are in action, and that is the combination of all of them. So a long story to cut it short is to say that from the sins of you as the investigator, you have not committed any sin because everybody had an equal probability of selection. But if the participants committed a sin by not responding, equally, or if there's differential non-response, we might still have to account for a different kind of weights, calibration weights, to account for that. So I hope that makes sense. It's a bit of a nuance, but I hope you get it.
Thank you so much, Prof. Thanks a lot.
You're welcome.
Thank you. So we've started sharing the attendance register. Please take a look at the chat panel and complete it if you would like to receive a certificate, but you will only receive a certificate after attending at least one of the 3 sessions. So it's not like every day we will be issuing certificates for each day attended, okay? So Elia just shared it. It will be shared throughout the Q&A session. For those who are joining us for the first time, it's an evaluation survey / attendance register, okay? Please be sure to provide your name and correct email address, full name and correct email address for certification purposes. Thank you. I'll go back to reading. Can I use publicly available datasets to publish a paper without going through ethical review?
Well, it depends. Okay, I will give a generic answer that meets, US law, but these things are subject to regional laws, right? So the Code of Conduct for US Human Research states that or accepts that publicly available data, as long as it does not contain identifiers, is deemed as non-human subject research. Right. So if you just most public data sets like the one we use, NYTS, there are no identifiers, right? So when we use this kind of data sets, well, in general, we, since they are non-human subject research, in general, we don't go through an ethical review board. But your institution may have its own rules, right? That's why I say the most important answer here does not come from me. That comes from your institution, what their rules are, or what your country level rules are. Your institution might say that, well, even if you're using publicly available data sets, that is not you that has the right to say ethics is not needed. You must go to an ethical board, and an ethical board will say that yes, ethics a full review is not needed, right? So in that case, you are given an exception by the IRB. An exception means that the IRB has decided that you are exempted from a full IRB review, but the IRB still needs to see it. So your organizational rules or your institutional rules take precedence. So without knowing the rules for your country or for your organization, it's very hard for me to say. But in general, public available data sets that do not contain identifiers are classified, at least by US law, as non-human subjects research.
Thank you, Prof. Next question. How does the platform ensure the confidentiality of the uploaded data set? Does the platform use uploaded data for any purpose beyond my analysis, such as training models or research?
No.
Will the data I upload to the platform be stored by the platform? And if so, for how long? And can I delete after using it? Who has access to it?
So when you upload data, the account is yours. The only person in the world who has access to it is you. Now, you might be doing, am I still sharing my screen?
No.
Okay, already. Actually, I am. It says I'm.
Well, you are, sir. It's just, it's the website. Yeah.
Okay. Already. So, now you might have collaborators, right? You know, of course, it's a collaborative platform, so you might choose to invite collaborators to your, let's say your survey, right? I may choose to say, I'll have a survey. Like here, someone has invited me to their survey. See, I have a pending invite. Now, if this person invites me to their survey and gives me a right to view the data, well, now I have access to that data set, right? Now, will the platform be responsible for that? No. So to keep the answer straightforward, we don't have access to your data set. We don't use your data set for anything. We don't keep your data set. We don't store it. We don't, to access it or use it. You can delete your data set at any time. But be aware that it's a collaborative platform, and when you invite people to a survey or anything, you can restrict their access. You can say, oh, this person, I want them to be able to do this, but not that. So you can control access to whoever you invite to your project.
Thank you, sir. Okay, next question. If I'm working on two complex survey datasets of two countries and I want to run a comparative analysis, but one of the datasets does not have PSU and the stratum, it only has the weight. How should I handle that? Is there a way to fix this issue?
No, there's no way to fix the issue. So the problem is that, remember that the issue with complex survey, remember I said that the weight variable control the up and down volume, and the PSU and strata control the width of the confidence intervals, right? If you generated an estimate with only weight but did not account for PSU or stratum, the point estimate will be correct. It's 100% correct. So, but the problem is that your confidence intervals will be too narrow, right? They'll be quite narrow. So what does that mean? It means, so, because when we analyze complex survey data, we don't subset data, right? Because the confidence intervals must be calculated among the whole population. So when you don't do that, the confidence intervals are pretty narrow. What the strata does is that it allows you to be able to, it forces them to expand them a bit, right? It realizes that, geez, you know what? This survey we did was not a simple random sample. So this is what's going on in your software when you account for PSU and strata. The software looks at the data and says, I know that you are not a simple random sample. I know that all of you came from the same household and that you're all very correlated, right? To punish you guys for that, I'm going to make your confidence interval a little bit wider, right? So, and what does wider confidence intervals mean? Well, wider intervals mean that there's more likelihood that they will overlap. Imagine, you have two confidence intervals that are very wide, sitting side by side each other. Well, since they're very wide, they will be touching each other, right? Just because they're wide. If they were not wide, they will not touch each other, and you will conclude that there is a significant difference between them. The danger from your study is that you are at risk of a type 1 error where you end up concluding that results are significant when they may not be in nature. And why did you conclude that? Well, because one data set doesn't have PSU or strata, the estimates are correct, but the confidence intervals are too narrow. And because they're too narrow, that they're likely not to overlap with the other estimates. And so you end up concluding that there's a difference. So in those kind of cases, you can still make a comparison, but keep them qualitative. In other words, don't die over this p-value business, right? You just keep it broad and say, okay, describe things, but be aware that you might have that problem. Now, if you really, really want to make inferential statistics, you can increase the confidence level from 95% confidence intervals to 99. So make it a bit more stringent. So those are some of the options that you could do, but you should be just aware of the implications of that action.
Thank you, Prof. My question is, how do we collapse sparse variables?
How do you collapse what?
Sparse variables.
Well, you can group them. If you have a sparse, a sparse category means it has very few people. So if I have a variable AB with categories of A, B, C, D, and there are only 3 people in one group and 2 people, I just group them together. If it makes sense to group them, right? It has to make sense because remember, we're telling the story. We can't just tell story with disjointed things. So statistical pursuits should only take precedence after we have considered common sense. Does it make sense to combine these particular 2 groups together? If it doesn't make sense, then why are we doing it, right? So we should just do things because we can, but because they make sense from an interpretation perspective.
Right. Basma, your hand is up. Please unmute.
Hello, Doctor. Thank you for your effort and explaining. Thank you very much. I have a question. Where do we get the data to start our project, and how to make sure that no one is working on it?
Oh, if you can get a data set from online, I mean, there in one of the sessions, maybe tomorrow or next, I will show you how to, sources for publicly available data sets. But yeah, it requires some, like in this case, this is where I got it, right? But there are hundreds or thousands of publicly available data sets. This is just one of them. Now, the more interesting question is your second question. How do you make sure that somebody is working on it? Well, you can't. There's no way you can know. And that's what we call being scooped. Being scooped means that, oh, you were working on this thing and, oh, suddenly you saw somebody published on the exact same thing you were working on. And that's why when you are working on public data sets, you should know that you don't have forever and ever. You have to be fast.
Fast, yes. Thank you very much. Thank you.
You're welcome, yeah.
Okay. Thank you, Prof, for this insight and very thoughtful platform to improve scientific research. Which of these estimates is correct in this scenario? In brackets, that's mean estimate, prevalence estimate, stratified prevalence estimate. Close bracket.
That's prevalence.
Okay. Continues. Age standardization research of a mortality outcome of a stratified age group from a known population, putting into consideration suppression rule to validate reliability of the result.
Yeah, so yeah, you would use prevalence. Means simply means that it's continuous variable. Prevalence means it's categorical, like the ones we're discussing.
Okay. Thank you. I don't know if there are questions I missed earlier. You can kindly post them again before we close the session. Is the Chi-Square system set up to execute checks with users when major descriptive tasks are completed? A checklist to give the user a fallback to consider key issues that may have been left out and could have been considered.
Yeah. So the way the platform is engineered is such a way that things pop up only when they need to pop up. So if you see a checkbox or some other thing, it's because it has considered all of the context. So and then it's saying that yes, you need to do this. So we we perform all the underlying tests or diagnostics, and it's shown to you in the form of the UI that you are seeing at that moment. So if you are doing, for example, let's continue with the example of the regression example we talked about. You're doing a linear regression, which we're going to cover on tomorrow, I believe, and you find that, geez, your variable is skewed. Well, before you found out that the variable is skewed, the platform has already found out that the variable is skewed. So it will then give you an option to say, oh, you might consider doing a log transformation. It will not show you that option for a log transformation if your variable does not meet the requirements. If, for example, you have a variable that has negative values or is left skewed, like, why are you showing the user log? Why are you trying to point them in the wrong direction, right? So the platform will not point in the wrong direction. So if you are seeing anything on your screen, it's because the platform has performed all the underlying diagnostics and has determined that, yes, in this case, this might be helpful. So that is how so all of those checks have already been performed and are provided for the user to engage with at their discretion.
Thank you. Can SPSS and data format data be imported to the Chisquares platform?
Yeah, you can import data in any format that exists.
Is the Chisquares platform only for quantitative data or mixed?
It's mixed, but it's optimized for quantitative data.
Okay. Well, I think that's all.
All right, awesome. Well, thanks everyone for attending, and I will see you in class tomorrow. We're going to post the homework, so please try your hand at it so that we'll have some incremental progress on. I mean, you already know what the homework is, but we're still going to post it officially though. All right, thanks everyone. See you tomorrow.
Thank you very much, Prof. Thank
Yeah,
you. Thank you, everybody. See you tomorrow. So, Prof, when is the homework due? Tomorrow?
Yeah, it's due tomorrow.
When?
Yeah, tomorrow.
Okay. All righty. Thanks.
All right. Cheers, everyone. Bye.
Thank you, everybody. Thanks, Ngozi.
The world has changed. Much that once wasn't has come. Few now remember how it began. It began with the forging of the great apps. 3 were created for sampling, beautiful, intuitive, precise. 7 for analysis and writing, each offering speed, but fractured by complexity. And 9 were made for survey design and data collection for robust studies that above all else required power. To each app was given functionality, the strength to govern a single part of the research process. But they were all of them deceived. For another app was made. In the depths of innovation, in the fires of ambition, Chisquares forged in secret a master platform. One app to unite them all, to bring analysis, writing, referencing and publishing into a single flow. And into this platform was poured brilliance, discipline, and the relentless will to transform science. One app to rule them all, one app to change research forever. The journey ends where it begins, with Chisquares. One day, one platform, one manuscript. Thou shalt not wait. Start and finish your manuscript today with Chisquares.